Introduction to Variability, Standard Deviation.
In the last topic, you were introduced to variability and learned about range, which is one of the tools used to measure variability. Another widely used measure of variability is standard deviation. You can think of standard deviation as a measure to understand how much the values in the data tend to stay close together or spread out. If it is small, the numbers are usually close to each other. If it is big, it is more spread out. Understanding variability is crucial in statistical analysis because it helps in making predictions and estimating uncertainty, identifying potential outliers or unusual observations, comparing different data sets or groups, and assessing the reliability and stability of data. Now let's go ahead and learn about standard deviation and the basic steps to calculate it. Standard deviation is a powerful tool which allows us to understand the spread and variability of data, identify outliers or extreme values, make comparisons between different data sets, and complement other measures like mean and range. You can calculate the standard deviation manually by following these steps. First, find the mean average of the data set. Second, subtract the mean from each data point to get the deviations from the mean. Third, square each deviation. Fourth, find the mean of the square deviations. Fifth, take the square root of the mean of square deviations to get the standard deviation. The formula for the sample standard deviation when dealing with a sample of a larger population, where xi represents each data point. X bar is the mean of the data set. Summation denotes the sum of the values, and n is the number of data points in the sample. Whereas the formula for population standard deviation when dealing with the entire population is similar, but uses n instead of n-1 in the denominator, where xi represents each data point. X bar is the mean of the data set. Summation denotes the sum of the values, and n is the number of data points in the sample. To understand the basic steps involved in calculating the standard deviation, start by imagining a group of numbers like test scores. Each number represents how well someone did in the test. The first step is to find the average of the numbers. The average is like the typical scores. To find the average, add all the scores and divide by the numbers of scores. In the second step, see how far the scores are from the average. Subtract the average from each data point. Here, you can know how far each score is from the average. If most scores are really close to the average, the standard deviation will be small. If some scores are far away from the average, the standard deviation will be bigger. In the third step, you need to find the square of differences. Squaring just means multiplying a number by itself. This is done to make sure all the differences are positive, because some are below the average, some are above. In the fourth step, find the average of the square differences. Add up all those square differences and divide by how many numbers of data points. This gives you the average difference from the average. In the fifth step, calculate the square root of that average. This step undoes the squaring done earlier, so we get a number in the same units as our original test scores. This result is the standard deviation. A low standard deviation indicates that data points are closely clustered around the mean, indicating less variability. On the other hand, a high standard deviation suggests that data points are more spread out from the mean, indicating greater variability. In simple terms, standard deviation helps us understand how much numbers in a group like to stick together, or how much they like to spread out. It's like a measure of how predictable or unpredictable the data is. Therefore, it is a crucial statistical measure